All right, how you guys doing? Hello, hello. So today we're going to be talking about area and perimeter of 2D shapes. So let's go over our objective real quick so that we know what we're learning about. I can use formulas and logical thinking to explain how to find the area and perimeter of various two-dimensional shapes. So when we talk about two-dimensional shapes, those are the kinds of shapes that we've already seen, such as triangles, squares, rectangles, rhombuses, pentagons, heptagons, all of those. Because when we talk about two-dimensional, take a look at this pentagon down here. Now you see that if I were to take this page out and look at it from the side, it'd be like a sheet of paper. There wouldn't be any depth or height here. It'd just be my pentagon on a sheet of paper, and that's as flat as it can get. That's what we mean by two-dimensional, that there's no height, there's no depth. So this only has vertical space and horizontal space. Obviously, diagonally is a combination of vertically and horizontal. If this had depth, like going inside of the page or outside of the page, then it would be three-dimensional. So now let's talk about perimeter and area. So what does that mean? What is that? So when we talk about perimeter, we're talking about the distance of the line around a closed geometric shape. So if I look at my pentagon again, all this line right here that goes around that shape, that's my perimeter. So you can imagine the perimeter being about something like a fence. If I have this garden in here, I build a fence around it. That's my perimeter. Because remember, closed means that I don't have any gaps, no way in, no way out, just like a fence. Now, area, on the other hand, area, get this out of the way, the amount of space that a closed geometric shape occupies on a two-dimensional plane. So going back to a garden, if this is my garden in here, how much space is that taking? That is what the area means. So all this green in here, all this grass, all these plants, whatever I have in my garden, that represents the area. So now that we defined perimeter and area, let's talk about how to find those for different shapes. We're going to start with a square slash rectangle because those two are very similar. So why don't we start with perimeter? One way that we can find the perimeter, as you know, is to just add all the sides together on a shape. So let's say that I have the base of my rectangle, and I'll do that in red, and I'll do the height in blue. And this applies for a square too, because remember, a square is a rectangle, but with all sides congruent. All sides are the same. So what I know about a rectangle and square though, two sides are the same to each other. So like these two are congruent and these two are congruent. So one way to find perimeter is to add all the sides together. But if you want a shortcut here, you want a formula that cuts this down a little bit. Well, since I have two sides here that are the same and these are my base, then I can have 2 times the base, and I'm going to be adding these, right? I'm going to add these with my height. And since I have two of those, then I can have 2 times h, the height. So my formula for perimeter of a rectangle or a square becomes 2 times the base plus 2 times the height. And you're not required to use this formula because you already know perimeter just means that all of the sides add together. So I can always use that to find perimeter. Like for example, this rectangle here, I have 1, 2, 3, 4, 5 blocks going sideways. And let me change that to red because that's my base here. And for my height, I have 1, 2, and 3. So 3 is my height. So if I want to find the perimeter here, then I can use my formula, 2 times my base plus 2 times my height. 2 times 5 is 10. 2 times 3 is 6. So my perimeter is 16. All right. Now area, on the other hand, remember that area means how much I have inside. So now if I want to find the area, I have to count the squares on the inside. So area, 15. But of course, we're not going to be able to count every single square in every single rectangle, especially when these dimensions start getting super big, like 20 by 50 or something. So instead of counting the squares, we'll use our formula. And if you notice, our base is 5, our height is 3. Our area was 15. What can I do with 5 and 3 to get 15? The answer is multiply them, because area is also base times height, 5 times 3. And if I do that, then I get 15. So my formula for area of a rectangle is base times height. I remember that when I have these two letters together, it means that I multiply them. No plus sign, no minus, no division sign, means that I multiply them. So here's my perimeter and area for a square or a rectangle. Both of those formulas work for both of those shapes. All right, so let's continue with our next shape, which is a parallelogram. Now, interestingly enough, we also have a base and a height for our parallelogram. Now, you might think that, hey, we did our rectangle here, but this rectangle doesn't look anything like our parallelogram. Well, that's true, but take a look at what happens down here if I do this. So I have a parallelogram here. Now I can count the squares inside. I can count the perimeter to get that. But remember, this isn't exactly one though. And the squares are cut here. But let's take this piece of my parallelogram. And if I shift this to the other side like this, well, look at that. I end up with a rectangle. So really, a parallelogram is a rectangle with this piece added over here like that. Which means I can use the same formulas to find the area and perimeter of a parallelogram. Those will still work. So if I have perimeter, I still have my base and height. Base is still here. Height is here. Now be careful with the height. This slanted side is not the height. We're going to call that S, meaning side or slant height. Either way, this is not the height that we're going to use in our area formula. So be careful with that. This is the height that we need. And how can we tell which one is going to be the height? Through here. Check it out. Wherever you see this little square, you know that's 90 degrees, which means the height and the base are always perpendicular. You're always going to have that right angle where the base and the height are. So now let's go back to our perimeter. So perimeter doesn't use this height at all. Perimeter actually uses the side length since we want the measures of the outside. Now we already know also that in a parallelogram, opposite sides are congruent as well. So we can actually use the same formula from a rectangle, 2 times base, but now instead of 2 times the height, we're going to use 2 times the side, the slant height. But for area though, area still has the exact same formula, base times height. Let's continue. Here's an example that we're going to do together to find the perimeter and the area of this parallelogram right here. So for the perimeter, now I know that this side here is 11, but I also know that these two sides are congruent because it's a parallelogram. So if this is 11, then this must also be 11. And if this is 15, then this must also be 15. And so if I add all 4 of these sides up, 15 plus 15, that's going to be 30. 11 plus 11, that's going to be 22. And if I add those two together, 30 plus 22 gives me 52. My units are meters. So my perimeter here is 52 meters. Now for area, we need our base, we need our height. So here, what's our base? Well, if I see my line here, I know that this is going to be perpendicular So that means that here is my base and here is my height. So for area, base times height. So 15 times 9, I'm going to pull up my calculator. 15 times 9, that gives me 135. So my area is 135, my units, meters. So that makes it meters squared. So my area, 135 meters squared.